guys, I am teacher Carla, and for today, we will be learning about whole numbers, factors, and multiples. Prepare your math notebook and let's get started.
To understand better our topic for today, take note of the different key terms. Whole numbers, real numbers, number line, number system, factors and multiples. In this chapter, you will define whole numbers, factors, multiples, and identify factors and multiples of given numbers. Also, in this chapter, you will explain what makes whole numbers, solve for factors and multiples of numbers, and demonstrate understanding of whole numbers on number line. It is important for us to learn about nature of numbers because it is the foundation of higher math concepts. To be able to understand higher math concepts, mastery of the basics is a must. Whole numbers is formally defined as the collections of positive numbers and zero but without fractions or decimals. Whole numbers is a part of the real number system. It is represented by the symbol capital letter W. These numbers are positive integers including zero and do not include fractions or decimals. Whole numbers can be understood better using a number line. A number line is defined as straight line with numbers placed at equal intervals or segments along its length. A number line can be extended infinitely in any direction and is usually represented horizontally. On figure 2.2, whole numbers is graph on a number line. The arrow part indicates that whole numbers has infinite number of elements on that side and that the list of elements goes on infinitely. Whole number are sometimes being mistaken to natural numbers because of their many similarities. All natural numbers are whole numbers, but not all whole numbers are natural numbers. The reason is because zero is an element of whole numbers while natural numbers does not have zero as its element. The starting number of whole numbers is 0 while natural numbers start with number 1. Both whole and natural numbers have positive integers as their elements. Natural numbers are part of whole numbers, but not all whole numbers are part of natural numbers.
We know that 4 and 5 are whole numbers. What is 4 plus 5? It's 9. 9 is also a whole number. Even the numbers 22 and 33 are whole numbers. What is 22 plus 33? You're correct. It's 55. And 55 is also a whole number. Are you getting a gist of what I'm trying to say? Also, if I add two whole numbers, 350 and 620, the answer to that is again a whole number. Similarly, 28,000 plus 59,000 also result in a whole number. Whenever we add any two whole numbers, the resultant number that we get is also a whole number. And this is the first property of a whole number. However, instead of this, we say that whole numbers are closed under addition. This is just a mathematical way of saying it. This statement is actually the same as this. If I add any two whole numbers, the number that I get will also be a whole number. Now here is a question for you to answer. Are whole numbers closed under subtraction? Pause the video and give it a thought. First of all, let's understand what the question means. What do we mean by closed under subtraction? It means that if we take any two whole numbers and subtract them, then we will always get whole number. Will this always happen? Let's try to find this out by subtracting any two random whole numbers. 35 minus 20 is equal to 15. We subtracted two whole numbers and we got whole number again. Similarly, 1000 minus 999 will give us 1, a whole number again. What about 5 minus 8? What will we get when we subtract 8 from 5? Wait a moment. Can we even subtract 8 from 5? No, we can't do that. Even if we try to subtract them, here's what we get. A negative number. We are not talking about negative numbers now. You will learn that in the future lessons. But we know that this is certainly not a whole number. Hence, we will term this subtraction as invalid. Similarly, if you subtract 100 from 50, the answer that you will get is a negative number. Both numbers are not whole numbers. So we can say whole numbers are not closed under subtraction. What about multiplication? Are whole numbers closed under multiplication? Yes, they are closed under multiplication. When you multiply any two whole numbers, you will always get a whole number. Here are a few examples to support this argument. 5 times 5 is 25, a whole number. 1 times 1000 is 1000, a whole number again. Let's involve the whole number 0. 0 times 10 is what? When you multiply any number with 0, we get 0 again. So it's 0. We take any two whole numbers and multiply them. The answer that we get will always be a whole number. Here's a quick recap of what we studied so far in this video. We learned that whole numbers are closed under addition, not closed under subtraction, and closed under multiplication. These three are arithmetic operations that we commonly use. Is there another one? Which is the fourth most common operation that you know of? It's division. I'm sure that you must have already guessed the next question that I'm going to ask you. Are whole numbers closed under division? 4 and 2 are whole numbers, and if we divide 4 by 2, we get a whole number again. But if we divide 6 by 5, the answer we will get will be in decimals, which is not a whole number. Similarly, examples such as 3 divided by 12, 4 divided by 9 will not result in whole numbers. Hence, we say that whole numbers are not closed under division. What is 0 divided by 4? It's 0. And what is 4 divided by 0? Is it also 0? Or perhaps some other number? In order to understand this, we first need to be sure that we know the meaning of division. We have studied arithmetic operations. And the fact is that among all the arithmetic operations, students find division to be the most difficult one. What is division? When we divide a number 8 with say 4, what actually are we doing? Imagine this scenario. There are 8 chocolates and 4 people. And we want to distribute these 8 chocolates to 4 people such that everyone gets equal number of chocolates. How many chocolates will a single person get? Each person will get 2 chocolates. How did we get this 2? Yes, we divided 8 by 4 and that gave us 2. Or in other words, we divided the number of chocolates available equally among all the people. Now let's say instead of 4, there are 2 people now. How will we divide 8 chocolates between 2 people? How many chocolates will each person get? You're absolutely correct. Each one will get 4 chocolates. Let's act a bit crazy now. Let us divide 8 chocolates equally among 0 people. That is, 8 divided by 0. Does it even make sense to divide 8 chocolates amongst no one? No, it doesn't. Hence, we say this is undefined. Or in other words, any whole number divided by 0 is undefined. On the same lines, these are all undefined quantities. We will see another property of whole numbers in the next video.
Word problem solving involving whole numbers. 1. Lee pays his bills every month. He pays 2,500 pesos for his electricity per month and 42,000 pesos every year for water and electricity bills. How much does he pay for his water bills monthly? Electricity is worth 2,500 pesos per month. In a year it is worth 30,000. Water and electricity bills costs 42,000 every year, less the cost of electricity in a year. Therefore, the water bill costs 12,000 yearly and there are 12 months in a year, so it costs 1,000 pesos per month. 2. A pizza place is offering a sale. Normally, one pizza costs 350 pesos. How much was he able to save if he bought 2 pizzas and got one more pizza for free? On a regular price, he would pay 1050 pesos for 3 pizzas, but, because of the sale, he only paid 700 pesos. Therefore, he saved 350 pesos because of the sale. Factors and multiples. Factors are numbers that divides other numbers exactly. Every natural numbers have 1 as its factor. All numbers are factors of itself. For example, 56 divided by 7 is 8. 56 is a whole number divided by another whole number, 7. The quotient is 8. Now, we call 7 as a factor of 56 because when divided, quotient is an exact whole number. If you will find all factors of 56, identify all numbers that can divide 56 exactly. Factors of 56 are 1, 2, 4, 7, 8, 14, 16, 28, and 56. Two. Find all factors of 120. Factors of 120 are 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 120. These are numbers that can divide 120 exactly. 3. Find all factors of 48. To be able to solve for factors of 48, we think of numbers that can divide 48 exactly. 48 can be divided exactly by the numbers 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Therefore, the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. 4. Find all factors of 210. To solve for factors of 210, we identify all numbers that when multiplied to each other the product would be 210. Therefore, the factors of 210 are 1, 2, 3, 5, 5, 7, 10, 14, 15, 21, 30, 35, 42, 70, 105, 210. 5. Find all factors of 82. Factor of 82 or the numbers that divides 82 exactly are 1, 2, 41, and 82.
Today, we will learn about factors. First, let us understand what we mean by the factor of a number. Let us take the number 12. To begin with, let us find out the pairs of numbers that give 12 as their product. 1 into 12 is equal to 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. So, we get 3 pairs of numbers that give us the product 12. No other pair of numbers, when multiplied, will give the product 12. Now, let us take each pair of number separately and understand what it means. Let us take the first pair. 1 into 12 is equal to 12. Here, when we divide 12 by 1, we get the quotient as 12. And when we divide 12 by 12, we get the quotient as 1. In both the cases, the remainder is 0. Thus, it means that 12 is divisible by 1 and 12. Pair 2. 2 into 6 is equal to 12. Here, when we divide 12 by 2, we get the quotient as 6. And if we divide 12 by 6, we get the quotient as 2. In both the cases, the remainder is 0. Thus, it means that 12 is divisible by 2 and 6. Pair 3. 3 into 4 is equal to 12. Here, if we divide 12 by 3, we get the quotient as 4. And if we divide 12 by 4, we get the quotient as 3. Here also, we get the remainder as 0 in both the divisions. Thus, it means that 12 is divisible by 3 and 4. Thus, we now understand that 12 is divisible by 1, 2, 3, 4, 6, and 12. Hence, we say that the numbers 1, 2, 3, 4, 6, and 12 are the factors of 12. Hence, we can define factor of a number as a number which exactly divides the given number. Or we can say that factors are numbers you can multiply together to get a given number. Now, let us look at certain points which we need to understand related to a factor with the help of some examples. Point 1. 1 is a factor of every number. Look at the examples. 1 into 6 is equal to 6. 8 divided by 1 is equal to 8. Thus, 1 multiplied by any number gives the number itself as the product, and any number divided by 1 also gives the number itself as the quotient. Hence, we conclude that 1 is a factor of every number. Point 2. Every number is a factor of itself. We know that 6 into 1 is equal to 6. 8 divided by 8 is equal to 1. Thus, any number multiplied by 1 gives the number itself as the product, and any number divided by itself gives 1 as the quotient. Hence, every number is a factor of itself. 3. The factor of a number is always less than or equal to the number. Look at the factors of 12 which we found out earlier. They are 1, 2, 3, 4, 6, and 12. Note that the factors 1, 2, 3, 4, and 6 are less than 12, and the last factor 12 is equal to 12. Thus, it shows that the factor of a number is always less than or equal to the number. 4. Every number except 1 has at least 2 factors, 1 and the number itself. Let us look at the factors of 7. They are 1 and 7. No other pair of numbers, when multiplied together, will give the product 7. That is, the number 7 has at least 2 factors, 1 and 7. That is, number 1 and the number 7 itself. Hence, we can say that every number except 1 has at least 2 factors, 1 and the number itself. Do remember these points properly. They will help you to find the factors as we go further. Now, let us find the factors of one more number. Let us take the number 30. The pairs of numbers which give the product 30 are 1 into 30 is equal to 30, 2 into 15 is equal to 30, 3 into 10 is equal to 30, 5 into 6 is equal to 30. Thus, the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Now, look at these factors and remember these points. 1. A factor of a number exactly divides that number. 2. 1 is a factor of every number. 3. Every number is a factor of itself. 4. The factor of a number is always less than or equal to the number. 5. Every number except 1 has at least 2 factors, 1 and the number itself. Wasn't it easy to learn about factors? Why don't you try to find the factors of some numbers yourself?
Multiples are numbers that results from multiplying a certain number to each and every counting numbers. All numbers are multiples of themselves. For example, if we will find the first 4 multiples of 12, we multiply counting numbers from 1 until 4 to 12. The product would be the first 4 multiples of counting numbers. Therefore, the first 4 multiples of 12 are 12, 24, 36, and 48. 2. Find the first SX multiples of 8. When 8 is multiplied to the counting numbers 1 to 6, the result is the first 6 multiples of 8. Therefore, the first 6 multiples of 8 are 8, 16, 24, 32, 40, and 48. 3. List first 10 multiples of 9. We multiply the counting number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the given number 9. The products are the first 10 multiples of 9. Therefore, first 10 multiples of 10 are 9, 18, 27, 32, 45, 54, 63, 72, 81, and 90. 4. List first 5 multiples of 10. Then first 5 multiples of 10 are 10, 20, 30, 40, and 50. 5. List the first 5 multiples of 13. We multiply the counting numbers 1, 2, 3, 4, 5 to the given number 13. The first 5 multiples of 13 are 13, 26, 39, 52, and 65.
Today, let us revise factors and multiples. Let us start with factors. What do we mean by a factor? A factor of a number divides that number exactly. Let us look at an example. Find the factors of 58. The first pair is 1 into 58 is equal to 58. Here, when we divide 58 by 1, we get the quotient as 58. And when we divide 58 by 58, we get the quotient as 1. In both the cases, the remainder is 0. Thus, it means that 58 is divisible by 1 and 58. The second pair of numbers which gives the product 58 is 2 into 29. Thus, the factors of 58 are 1, 2, 29 and 58. Let us solve one more example. Find the factors of 81. The pairs of numbers which give the product 81 are 1 into 81 is equal to 81. 3 into 27 is equal to 81. 9 into 9 is equal to 81. Thus, the factors of 81 are 1, 3, 9, 27 and 81, as each of these numbers divides 81 exactly. Did you notice we counted the repeated factor only once? Remember, every number has 1 as a factor. Every number is a factor of itself. Thus, every number except 1 has at least 2 factors. 1 and the number itself. The factor of a number is always equal to or less than the number. Now, let us look at multiples. A multiple of a number is the product obtained when the number is multiplied by the same or any other number. Let us find the multiples of 12. It is easy. When we multiply 12 by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, we get 0, 12, 24, 36, 48, 60, 72, 84, 96, 108, 120 and so on as the products. So here, the products obtained are nothing else but the multiples of 12. Let us look at another example. Find the multiples of 19. When we multiply 19 by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, we get 0, 19, 38, 57, 76, 95, 114, 133, 152, 171, 190, and so on. Thus, the multiples of 19 are 0, 19, 38, 57, 76, 95, 114, 133, 152, 171, 190, and so on. Remember, a number is a multiple of itself. Every number is a multiple of 1. Every multiple of a given number is equal to or greater than the number itself. Every number has an infinite number of multiples. 0 is a multiple of every number, but 0 is not a factor of any number except 0. Revising factors and multiples was fun.
Whole numbers is a collection of positive numbers and zero without any fractions and decimals. Factors are numbers that divides other numbers exactly, while multiples is the product when a certain number is being multiplied to every counting number. Try this activity.